Imagine for a moment that you had the power to travel back in time. Where would you go? What would you do? Would you revisit history, witness events unfold, or perhaps rectify past mistakes? This is the enigma of time travel, a concept that has intrigued mankind for centuries. This fascination has touched every corner of our culture, from classic literature to modern cinema, with tales of adventurers navigating the vast ocean of time. The allure of time travel lies not only in its potential to reshape the past, but also in the profound questions it poses about the nature of reality itself. However, the concept of time travel isn't all grand adventures and heroic deeds. It's a Pandora's box of paradoxes and dilemmas. What happens if you alter the past? What if you meet your younger self? These are just a few of the mind-boggling paradoxes that time travel presents. Yet, as thrilling as the idea of time travel may be, it comes with its own set of challenges and paradoxes, which we will explore in the next scene. To truly grasp the implications of time travel, we must first understand what it really means. So, let's dive right into it. Time travel, in essence, is the concept of moving between different points in time, just as we move between different points in space. But it's not as simple as hopping in a car and driving from yesterday to tomorrow. You see, our understanding of time travel is largely based on two key theories in physics: relativity and quantum mechanics. Einstein's theory of relativity, for instance, tells us that time and space are intertwined in a four-dimensional fabric known as space-time. Picture it as a trampoline, where the ball rolling around represents a celestial body, and the dips and curves it creates as it moves. That's the warping of space-time. Meanwhile, quantum mechanics introduces us to the realm of the very small, where particles can exist in multiple states at once and even teleport through barriers. This quantum weirdness could potentially allow for shortcuts through space-time known as wormholes. Imagine folding a piece of paper so that 2 points touch. The wormhole is the bridge that connects those 2 points, allowing you to move from one to the other instantaneously, bypassing the space in between. Now, it's important to mention that these theories are still just that, theories. We've got no definitive proof that time travel is possible, and even if it is, it would likely require energies and technologies far beyond our current capabilities. But let's not let that dampen our spirits. After all, the absence of evidence is not evidence of absence. The idea of time travel continues to captivate scientists and lay people alike, sparking countless discussions, debates, and sci-fi stories. So if time travel might be possible in theory, what would happen if we actually traveled back in time? Let's delve into this fascinating question. Traveling back in time isn't as simple as hopping into a time machine and pushing a button. It's a journey fraught with paradoxes and contradictions. Let's dive into two of the most notorious time travel paradoxes, the grandfather paradox and the bootstrap paradox, and see how they challenge our understanding of cause and effect and question the very nature of reality. Imagine this. You've built a time machine, and you decide to travel back to a time before your grandfather met your grandmother. In some unfortunate event, you accidentally cause your grandfather's demise. This poses an intriguing question. If your grandfather passed away before meeting your grandmother, your parent, and in turn, you should never have been born. But if you were never born, who traveled back in time to cause your grandfather's demise? This is known as the grandfather paradox. On the other hand, the bootstrap paradox, named after the phrase, pulling yourself up by your bootstraps, involves an item or piece of information sent back in time, which becomes trapped within an infinite cause-effect loop. Suppose you invent a time machine, and you receive detailed blueprints of its design from your future self. You then use those blueprints to build the machine. But who originally designed the machine? If you received the blueprint from your future self, who had it from your past self, and so on, then the design seems to have no origin. This is the bootstrap paradox. These paradoxes play with the concept of cause and effect, suggesting that the effect can occur before the cause. They challenge our linear perception of time, where events happen in sequence from past to future. They hint at a universe where time might be more flexible than we think, with events intertwined in intricate, perhaps even unknowable ways. These paradoxes demonstrate the complexity of time travel and the profound questions it raises about the nature of the universe and our place in it. Scene script. Assuming we could navigate the paradoxes, what would happen if we actually traveled back in time? Picture this. You've journeyed back to the past, and you've just stepped on a butterfly. Seemingly insignificant, right? However, this tiny action could spark a chain of events leading to a drastically different present, a concept known as the butterfly effect. The butterfly effect suggests that small changes can lead to significant consequences. It's a concept born from chaos theory, where minute alterations in a complex system can trigger far-reaching changes. In the context of time travel, this could mean that the smallest action, say, preventing your parents from meeting, could erase your very existence. But it's not just our personal timelines at stake here. Changing past events could alter the course of human history. Imagine if a key event, like the discovery of fire or the invention of the wheel, never happened. Our world as we know it might cease to exist, replaced by a reality shaped by different historical milestones. And then, we come to the ethical implications. If you could travel back in time, should you prevent tragedies or correct past mistakes? It's a tempting thought, but meddling with time might lead to unintended consequences. What if preventing a disaster in the past leads to a greater catastrophe in the present? Moreover, the power to change the past could easily be misused. Imagine if someone with malicious intent got their hands on a time machine. The potential for damage would be immense, and the effects irreversible. Ultimately, the concept of time travel forces us to grapple with some weighty questions. How much control should we have over our past? What are the moral implications of altering history? And can we ever truly predict the impact of our actions on the future? Time travel, as we see, is a deeply complex and fascinating subject, offering endless possibilities for exploration and speculation. It challenges our understanding of the universe and invites us to imagine a world where the boundaries of time are not as rigid as we once believed.